that are the same. Okay, so here when we're finding our x-intercepts, that trinomial is giving us two of the same brackets. Oh, sorry, it's frozen. Here we go. That trinomial is giving us the same two brackets. So it's essentially two x-intercepts that are like on the same point, right? Which is why it becomes a turning point. Okay, for your turning point, you take your derivative, make it equal to 0. This was a very simple one. Okay, you just divide through by 3. And guys, sometimes when you get something like this, you think for a second, I don't know what to do because it's not a trinomial, right? But you can still just take out x as a common factor. Meaning that here, x is going to be 0 or your bracket is going to be 0. Okay, so you are still getting two x values there. The first one is x equals 0. The second one is x equals 2. Now, guys, interestingly enough, I don't know if you found it interesting, but yeah, I did. So here, your one turning point was actually a y-intercept. And your other turning point was one of your x-intercepts, right? So when you're getting x equals 0, of course, you can sub it into that equation, but you're going to get y equals 4 anyway, right? Because where x is 0, y is 4. That's where you have your y-intercept. And for the x-intercept, that is the one that was a double x-intercept. That one will always become your turning point, one of your turning points. Any questions? We're just going to practice more of these today. So if you weren't able to get this one right, then you are going to have time to sort that out. Okay, I'm just going to move to the side so that you can see the graph and calculating that point of inflection. So the point of inflection is always your second derivative equal to 0. So there the point of inflection was at x equals 1. You sub that into your equation then of the function to get the y value. But again, we can see that the point of inflection is exactly halfway between the two turning points. Now, guys, if you have this question, right, say the first question was draw the graph. Now they're asking you, where is this graph concave down? Right, concave down. I actually want us to make a little note underneath because we spoke about it on that picture, but we haven't actually like answered it as a question. So I'm just going to write here underneath concave down. Concave down is like a downward facing parabola, right? So that is now the section of the cubic graph that is on the left of your point of inflection. So how are we going to write that, guys? How are we going to express that it's this part of the cubic graph? We're going to have to say where x is less than 1. At that point, it's neither concave up or concave down. It's the point of inflection is where it changes its concavity. So this section is concave down. So we're going to say where x is less than 1. If they're asking for where is this graph concave up, it's going to be the part that looks like an upwards facing parabola, but from the point of inflection to the right. Okay, so we're going to have to say there where x is greater than 1. Sorry, maybe I should just move this up a bit because I do want to add some more to that. Let's quickly write down where is this graph increasing. These are now all types of questions that they can ask you if they're giving you the graph or once you've drawn the graph. So increasing, that is where it's going up, right? So do we agree that this section is increasing? Right, so how are we going to express that? That is where x is smaller than 0. Do you agree? Because it's going to have that shape forever and ever, right? Because of this arrow. So this section from negative infinity essentially to 0 is increasing. So we can say where x is smaller than 0, or what about that section as well? Hey, where x is greater than 2. And what about decreasing? This bit, right, between the two turning points. So from 0 to 2. So you can write it in inequality notation, or maybe you prefer interval notation, especially for the ones where you have two boundaries. I think sometimes you guys prefer writing it like that. So x is an element from 0 to 2. It's up to you. You can decide which notation you want to use. I'm not including the turning points because at the turning points, that's also where it changes from being increasing to decreasing or decreasing to increasing. Okay, so we don't actually include those turning points. All right, it is still early days, guys. We are going to do more questions where they also give you a graph and we answer a whole bunch of questions on it. So we're just easing ourselves in. So don't stress about this too much just yet, yeah? Yeah. So you're going to have your crib sheet and the formula sheet. Yes. Okay, guys, I do want to just quickly draw one graph with you. It is a graph that only has one turning point. So I just want to show you how we're going to deal with that. So if you can just make another heading saying, what will this be? Example 3 actually. Hey, because this one that you did was labeled as example 2. So I'm just going to make example 3 now. See my spacing. Okay, guys, we're going to do all the same calculations. I would like you to do the calculations on your own, right? The same ones that you have to do for homework. You're going to find the y-intercept, x-intercepts, 1, 2, maybe you'll see, maybe 3, turning point, point of inflection. Okay, what I do want you to do here is before you do that, you're going to have to multiply this out. Okay, so that's a bit of algebra practice, multiplying out a cubic bracket, or bracket cubed rather. Guys, it's not just going to be x cubed plus 1 cubed, all right? I can warn you, it's not going to be that. So you're going to have to do 3 brackets and multiply them out. Okay, so I'll give you a little while to do that. It might take some time. Yes. Thanks, Amy. Mm, mm. Yeah, so when you factorize, when you make it equal to 0, you can divide through by negative. Guys, I just want to show you the equation of the graph quickly in case you, yeah, just so that you don't get that wrong and then everything else will be wrong as well. Okay, so that is what I got for the final function, the actual equation of the graph. Do you guys agree with that? So let me just take you through the steps. When I have to cube a binomial, I always do it like this. I always say it's one bracket and then I put the other two together as a bracket squared, and then I square that out first, and then I multiply the x plus 1 by each of those three terms. So guys, this is a lot of like, yeah, what's the word that I'm looking for? It's like you have to be very careful there, because if you make one multiplication error, obviously that throws everything else out. You probably won't get a question like this in a textbook exam. They might give you something like this where they'll say, show that the equation is this thing. So that even if you're making a mistake with your multiplying out, you can still work with that actual equation when you are finding the points and so on. And guys, there is some tiny stuff happening with this graph. So if you're getting answers that you're not used to getting, it's fine. You are supposed to be getting interesting things happening with this one. To find your x-intercepts, however many of those there are, turning point, point of inflection. Have you been able to find x-intercept stuff? Okay, so y-intercept, I think we all find the y-intercept being 7, right? Okay, that's a point. There, that is what happens when you try to calculate the x-intercept. So obviously our a value is negative here. So first divide through by -1. All right, you are allowed to do that in an equation. You can just divide every single term by -1, but you're actually dividing the 0 by -1 as well on the other side, right? It's just that 0 divided by -1 is 0 anyway. So then I'm hoping that you guys were able to get that 1 works for that equation if you sub it in, which is quite nice. 1 is usually the first one that I try. So x minus 1 is that first bracket. Then from there, you have to say, okay, what if I multiply x by to get x cubed? It's going to be x squared. If I look at this product, this is negative x squared, but I need a positive 3x squared. So what if I add to negative x squared to get positive 3x squared? 4x squared, right? Which I am going to get with that product there. X times 4x is 4x squared. And then what must you multiply -1 by to get -7? Positive 7. Now guys, this you might not have written down, but I just wanted to remind you of this, okay? You probably would have used the quadratic formula, and then it comes up as math error. And then the reason for that, guys, is because your delta, you guys remember that delta, we did that with nature of roots last year, very early in the year, so you might have forgotten. Delta is actually what you have in your square root in the quadratic formula, right? The quadratic formula is minus b plus minus the square root of b squared minus 4ac, which is what delta is. So if delta is -12, guys, that means that you're going to have the square root of -12. That's why the calculator says math error. Can't calculate that. Okay, so that just means that there is no real solution for this. You don't have to write it down like I did. This is optional. All right, you are also allowed to just do the quadratic formula and see that it doesn't work and then leave it. Or you can write no real solution underneath. But guys, if you're looking at this trinomial and you ask yourself, I'm looking for factors of 7 that when I add them together, it's going to give me 4. Right? That makes no sense. That's not possible. Do you agree? Factors of 7 are 7 and 1. And if you add them together, it's going to give you 8. So this trinomial does not have an answer. You can't factorize it. You can't solve it. So what does that mean? We only have one x-intercept. That's already quite strange, hey? The ones that we've done so far, I've had 3 x-intercepts. Okay, carry on. Find your turning points, your point of inflection as well. For AC. In the square root, yeah. Okay, can we look at turning point, guys? Tell me what's your question? Yeah. The original derivative, yes. Or the original function. Okay, guys, that is what I got for my turning point. Right, so the derivative, you make that equal to 0. So like what Talia was asking now, when you are finding the derivative, it has to be of the original function, right? So of this one with that minus in front. That's very important. This, what we did here was simplifying it so that we could solve. Okay, but the actual function was a negative x cubed function. So we have to keep that negative there. What I did here is I just divided through by -3 to turn it into a simpler trinomial. So each term I divided by -3. Now, guys, if you're looking at this trinomial, you can ask yourself, I need factors of 1 that when I add it together will give me 2. That's quite an easy one, right? Factors of 1 can only be 1 and 1. And when you add 1 and 1 together, you do get 2. All right, so if you want to just factorize this, it's going to be x plus 1, x plus 1. But this is now the same bracket twice. So in the previous questions, we had double x intercepts, which then ended up being, which then ended up being a turning point as well. If it was a double x intercept, it was a turning point as well. Now we actually have a double turning point. So can you guys already think what's going to happen here? If it's a double turning point, it's going to be the point of inflection as well. Okay, and when you actually do calculate that, you will see that you get the same point as your point of inflection here. Fatima, what is your question? Oh, I subbed it into the original equation. Yeah, so to get y equals 8, remember you take your x value, you always sub it back into the original function, always. Okay, so I can show you point of inflection calculation so long because I've already given it away. We're going to get that same point. So you can make your second derivative equal to 0. Sorry, let me just move this thing up here. Second derivative equal to 0, which is -6x minus 6. And then you're going to solve for x and you're going to get the exact same point. So guys, if you know this, right, if you know that a double turning point is going to be the point of inflection as well, you don't actually have to do the calculation, right? So it can save you some time if you get a question like this. Yes. Always original, yeah. But because I saw that it was the same x value, I know already that it's going to have the y value of the point above. Okay, now I want you guys to plot these points. We only have 3 points now. Okay, don't try and connect them yet because I have to show you how you are going to connect them. You have to connect them in a very specific way. But you can plot them so long, please. So you have 0, 7, you have 1, 0, those are the 2 intercepts, and then we have -1, 8, which is both the turning point and the point of inflection. Okay, there we go. I'm just going to label this point once I've drawn the graph because I'm not exactly sure where it's going to go. But those are the 3 points that we have. right? That doesn't look like a traditional cubic graph. Do you guys agree? We're not 100% sure how to draw this. Now, like I suggested, let's circle the one that is a turning point. But now we also know that that is not only a turning point, it's also a point of inflection. What happens at a point of inflection again? The concavity changes. So it changes from being concave up to concave down, or concave down to concave up. Okay, I can at least draw this part of the graph, right? Because we know, okay, it's going through that point there. So we know that this section of the graph is going to be what? If my graph is going here, that's concave down. Do you guys agree? Right from here, there, that point, down, down, that's concave down. It looks like a downward facing parabola, that section. Now, because this is a point of inflection, it's supposed to change to being concave up from here. So guys, can it go down again? Is it actually going to cut the x-axis again? We only got one x-intercept, right? So we can't possibly make this graph turn and go back down after this point, or before this point, actually. So you are going to draw something. Let me show you the graph in the book so that you can see. You're going to draw something that looks like that. Can you guys see that? There we have our turning point slash point of inflection. You have your y-intercept at 7. You have your x-intercept at 1. At this point, guys, you have to make a flat plot, because what we actually have there is 2 turning points. It's almost as if the graph is turning twice at the same point. So we have to make that section like a flat section to indicate that it is a double turning point. But then on the other side of that point, your graph has to go up. It has to be concave up, because on this side it's concave down. On the other side of the point of inflection, it has to be concave up. All right, I'm going to try and draw it now on my thing here as well. So it's almost like a tan graph in a sense, but they're at that point where it like turns up, you have to have a flat section. Okay, like that. Guys, if you really don't know what the graph is going to look like in this section, what can you do? If you have no idea, you have these 3 points, you know, okay, it's obviously going to look like that. What happens here? What can you do to get a point here? Yes, yeah, I wasn't even thinking about that, but that is one thing that you could look at, right? The A value here is negative. So remember on, I don't even know when it was now, we say that if your A value is negative, your shape is either going to look like that, or if you have only one turning point, which is what we have in this case, like this. Right? We did write it down somewhere. I'm sure you'll be able to find it. Okay, that is because we have a negative A value for this graph. We're going to have a shape that's either like that if you have 2 turning points, or like that if you have 1. Okay, but guys, what I was going to say is you can also always just sub in an x value over here and see what you get as your y value, right? If you maybe sub in x equals -2, you'll see, okay, I'm getting a value that's bigger than 8 now for y. So that means that my graph has to go up. Okay, I'm just going to make a little note here. This is a point of inflection. Therefore, concavity has to change. And also because it's a double turning point, you have to have a flat, I always say flat, but that's not really mathematical terminology. Flat, let's say section on either side. Hey guys, I have never seen a graph like this being asked in the matric final exam, but you never know, maybe this is the year. I hope that makes sense. Right. Okay, I'm going to give you 2 graphs to draw, and that is all that you will be doing for the rest of this hour. You'll probably finish before the end of the lesson. And then tomorrow we're going to be doing calculations from the graphs. Okay, are we all done with that? Can I take that off the board? Okay, oh, I actually don't have space left on this page. All right, you are going to, I think it's the same exercise. Oh, I actually just wrote an equation down. Okay, so it's exercise 9.1. On page 216. Okay, number 4 and 8. I can write down the equations for you because that's all they're giving basically. Guys, just a note on number 4, there is no constant term. So what is a constant term then technically? 0, right? So I'll put that in blue just as a reminder. Okay, so that is going to be your y-intercept. Your y-intercept is going to be 0, so the origin. Okay? But then when you have to now factorize this, when you make this whole thing equal to 0 and you have to factorize, isn't that an easy one to do? What can you do there to factorize? Take out x as a common factor. How lovely. All right, take out x and then that will give you your trinomial and then you can factorize. So you don't even have to do that like testing on the calculator to see what makes it equal to 0. You can just take out x as a common factor right from the start, and then that will give you x equals 0 for your one x-intercept, and then your other two you can get from it. Number 8 is also f of x. Okay, I want you guys just to do like what we did now in class. Again, you're going to find y-intercept, x-intercept, turning points, point of inflection, and draw the graph.